In the last video, we explained what the F-47 is and why the United States believes it is necessary. We talked about air dominance, networks, AI, and why the old way of fighting in the sky is ending. But that was only half the story. This video exists because there is another side to the F-47 program that rarely gets attention. The part that is harder to explain, the part that raises uncomfortable questions. According to U.S. defense officials and Air Force leadership, the F-47 is not just expensive, it is a gamble. It depends on technologies that are still evolving. It relies on software, data links, and artificial intelligence working perfectly in combat conditions. And it assumes that future wars will follow the path American planners expect. Defense analysts have pointed out that programs like this carry real risks. Budgets can spiral, timelines can slip, adversaries can adapt faster than predicted. History is full of advanced weapons that looked unbeatable on paper but struggled in the real world. So in this video, we are not here to sell hype. We are here to look at what the F-47 really means behind the headlines, the costs, the trade-offs, the doubts, and the questions that still do not have clear answers. Because understanding the future of air combat is not about believing promises. It is about understanding the risks behind them. Act 1. Behind the Program. NGAD Realities. To really understand the F-47, you have to stop thinking in terms of a single aircraft. From the very beginning, U.S. Air Force leaders have said that NGAD was never meant to be the next fighter jet. According to senior Air Force officials, it was designed as a family of systems where the manned aircraft is only one part of a much larger structure. This is why NGAD feels invisible. There are no official photos, no detailed public specifications, no dramatic reveal. The Air Force has confirmed that early NGAD demonstrators flew years ago, but almost everything about them remains classified. This level of secrecy is unusual, even by military standards, and it is deliberate. According to Pentagon acquisition officials, secrecy protects more than just the aircraft's shape. It protects how the system works, how data moves, how decisions are made, and how different pieces communicate in combat. Revealing those details would make it easier for adversaries to build counters. Another major shift is how the program is built. Unlike older fighter programs that relied on one prime contractor handling nearly everything, NGAD spreads the workload. Boeing leads the manned aircraft effort, but other companies develop the AI software, sensors, communication systems, and autonomous drones. Defense industry briefings have confirmed that these elements are developed in parallel, not in sequence. This changes everything. In past programs, delays in one area could stall the entire aircraft. With NGAD, different parts can move forward independently. If a sensor improves faster than expected, it can be integrated later. If software needs rewriting, the jet does not need to be redesigned. According to Air Force planners, this flexibility is critical because modern threats evolve too quickly. A fighter designed once and frozen for decades would fall behind long before the end of its service life. That is where modular design comes in. In simple terms, the F-47 is built like a platform, not a finished product. Its systems are meant to be replaced, upgraded, and reconfigured over time. New sensors, new AI tools, new drone partners, all without starting from scratch. This approach reflects a hard lesson learned from past programs. Technology ages faster than aircraft. And that leads to the most important idea of NGAD. The F-47 is not meant to dominate the sky by itself. It is meant to coordinate dominance, pulling information from satellites, drones, other aircraft, and ground systems, then turning that information into faster decisions. The jet you see is only the surface. The real weapon is the network behind it. Act 2. Cost, procurement, and controversy. The moment the F-47 became public, the debate shifted from capability to cost. The U.S. Air Force has not released an official price for the aircraft, but defense analysts and former Pentagon budget officials agree on one thing: the F-47 will be extremely expensive. Based on statements from Air Force leadership and comparisons with previous programs, experts estimate the per-unit cost could reach several $100 million, potentially exceeding the cost of the F-22. But focusing only on the aircraft price misses the larger issue. According to U.S. Air Force acquisition officials, the F-47 is designed to operate as part of a connected combat system. That system includes autonomous wingman drones, artificial intelligence software, sensor networks, secure communications, and space-based assets. Each of these elements requires its own funding stream, testing, maintenance, and continuous upgrades. Defense analysts have pointed out that modern military systems are no longer buy once and fly. Software must be updated constantly. AI models must be retrained as threats evolve. Drones will be lost in combat and replaced regularly. Cybersecurity costs will never end. Over decades, these expenses can exceed the cost of the aircraft itself. This has raised red flags. Government accountability groups and defense economists have warned that highly complex programs often face cost growth over time. They point to past aircraft programs where advanced technology led to delays, reduced production numbers, and difficult trade-offs. Their concern is not just the total cost, but what happens if budgets tighten. If fewer F-47s are purchased, the fleet becomes smaller and more fragile. Losses in a high-intensity conflict could be harder to replace. Critics argue that even the most advanced aircraft cannot be everywhere at once. Supporters of the program see the situation differently. According to senior U.S. Air Force officials, the real cost comparison is not between the F-47 and older fighters. It is between maintaining air dominance and losing it. They argue that losing control of the air would expose aircraft carriers, air bases, and ground forces to attack, driving costs far beyond any aircraft program. From this perspective, the F-47 is not an optional upgrade. It is a strategic necessity. The Air Force also argues that fewer, more capable systems can achieve effects that once required much larger fleets. Networked aircraft, drones, and sensors can concentrate power where it matters most. Still, the question remains: is the United States investing wisely in the future, or betting too heavily on technology behaving exactly as planned? That question has no easy answer and no second chances.
Act 3. Why dogfights are ancient history. For decades, air combat was defined by one image: two fighter jets circling each other in a tight turn, fighting for position at close range. Speed, agility, and pilot skill decided who lived and who didn't. That image no longer reflects reality. According to U.S. Air Force combat studies and modern conflict analysis, long-range air combat is now the standard, not the exception. Today, most air-to-air kills happen before pilots ever see each other. Engagements are decided by sensors, data, and missiles launched from far beyond visual range. This shift began years ago, but is now unavoidable. Modern aircraft no longer rely on a single radar. They fuse information from multiple sources: onboard sensors, satellites, other aircraft, drones, and ground systems. Defense analysts refer to this as sensor fusion, but in simple terms, it means pilots see a clearer and earlier picture of the battlefield than ever before. According to Air Force officials, this shared picture allows aircraft to detect threats at extreme distances. Once detected, modern beyond visual range missiles can be launched long before a traditional dogfight could even begin. As a result, close-range combat has become rare, not because pilots lack skill, but because survival depends on avoiding detection altogether. This leads to an important distinction. Air superiority means having an advantage in the air. Air dominance means the enemy cannot effectively operate at all. According to U.S. military doctrine, dominance is about denying the opponent the ability to fight, not just outflying them. In this environment, maneuverability matters less than information. Stealth aircraft reduce detection. Networks share targeting data. One aircraft may never fire a weapon, but still enable another platform to strike. According to defense planners, the aircraft that turns the fastest is no longer the most dangerous. The aircraft that sees first and connects best is. This is why programs like the F-47 prioritize stealth and networking over extreme dogfighting performance. The goal is not to win a turning battle. The goal is to never enter one. Modern missile-heavy battlefields punish exposure. Advanced air defenses and long-range weapons make lingering in contested airspace deadly. Survival now depends on being invisible, unpredictable, and connected. The romantic era of air combat has faded. The last true dogfight may already be behind us, and the aircraft of the future are being built for a very different kind of war.
Act 4. What if the F-47 fails? Every major military breakthrough comes with an unspoken question. What happens if it doesn't work as planned? According to U.S. defense officials, the F-47 is built around the assumption that stealth, networking, and AI will continue to provide a decisive edge. But history shows that no advantage lasts forever. Adversaries study, adapt, and respond. One of the most serious concerns is the future of stealth itself. Defense analysts have noted that China and Russia are investing heavily in new detection methods. These include improved radar systems, passive sensors, and multi-band tracking that look for aircraft in different ways, not just traditional radar returns. If stealth becomes easier to detect, the F-47 loses one of its most important layers of protection. Survival would then depend entirely on speed of decision and electronic warfare. Another risk lies in the system's dependence on software and artificial intelligence. According to Pentagon cybersecurity assessments, networked battlefields introduce new vulnerabilities. AI systems can fail in unexpected ways. Data can be corrupted. Communications can be disrupted or spoofed. In combat, even a brief loss of situational awareness can be fatal. Unlike mechanical failures, software problems may not be visible until it is too late. There is also the risk of cyber attack. Military officials have openly acknowledged that future conflicts will include aggressive cyber operations. If an adversary can disrupt data links, confuse sensor feeds, or degrade AI decision support, the advantage of a connected system could quickly become a liability. A pilot surrounded by bad data is more dangerous than a pilot with no data at all. Autonomous drones introduce another layer of uncertainty. While loyal wingman drones are designed to reduce risk to human pilots, defense analysts warn that drone swarms can be countered. China, in particular, has demonstrated interest in mass drone tactics designed to overwhelm sensors and defenses. If adversaries can neutralize or jam drone support, the F-47 may be forced to operate in a degraded mode. Then there is the issue of logistics. Advanced aircraft demand advanced support. According to U.S. Air Force sustainment reports, stealth coatings, sensitive sensors, and secure electronics require specialized maintenance. Supply chains must remain intact. Spare parts must arrive on time. In a major conflict, these systems could be targeted long before the aircraft ever take off. This creates a fragile ecosystem. A fighter that cannot be maintained, repaired, or updated is grounded, no matter how advanced it is. The real danger is not a single failure. It is cascading failure. A broken data link leads to poor decisions. Poor decisions lead to losses. Losses reduce confidence in the system. And once confidence is lost, the entire concept begins to unravel. The F-47 represents a bold bet on the future of warfare. If it succeeds, it could redefine air combat for decades. If it fails, the consequences would not be technical, they would be strategic.
Act 5. The strategic implications. The F-47 is more than just a jet. According to U.S. Air Force strategy briefings, it represents a shift in the very nature of air power. Success or failure will not just affect a single conflict, it could reset the global balance of air dominance for decades. If the F-47 lives up to its promises, it would allow the United States to control the skies in a way no single generation of fighters has ever achieved. By linking manned aircraft, autonomous drones, sensors, satellites, and AI-driven networks, the U.S. could detect and respond to threats faster than any adversary can react. Analysts at Defense News and the Center for Strategic and International Studies have emphasized that this networked approach is fundamentally different from the traditional model of fighter superiority. In the past, air dominance meant having faster, stealthier, or more maneuverable aircraft. Today, dominance means having better information, faster decision cycles, and the ability to act on that information before the enemy even knows what hit them. On the other hand, failure carries equally profound consequences. Defense planners warn that if the system cannot operate as designed, if AI fails, drones are neutralized, or data links are disrupted, adversaries like China or Russia could gain a strategic advantage. They could field larger fleets of conventional aircraft, invest in counter-stealth technologies, and exploit vulnerabilities in supply chains or software networks. Failure would not simply mean losing a plane or two, it would mean losing the ability to shape the battlefield from the first moment. This reality highlights a crucial point. The real contest in modern air warfare is no longer about individual jets or pilots. According to senior U.S. Air Force officials, it is a war between systems, networks, and capabilities. Air superiority now depends on the flow of information, the speed of AI-assisted decisions, and the ability to coordinate multiple assets across vast distances. Even the most advanced jet becomes nearly irrelevant if it cannot participate in this networked ecosystem. The F-47 sits at the center of this transformation. It is both a symbol and a tool of a new kind of power. If it succeeds, the U.S. will not just control the skies, it will control the fight before it begins. If it fails, it will provide lessons for rivals and a cautionary tale for the limits of technology. And that is why understanding the F-47 is critical. It is not just a fighter, it is a statement about the future of warfare itself. If you want to stay updated on how air combat is evolving and understand the technologies shaping tomorrow's battles, subscribe for more deep dives into the future of warfare.